Jim, thanks for all. But seriously, let me switch over.
me?
Sure. Yeah, mine. Actually, this team would probably.
Okay.
You're up there, aren't you?
I don't know.
You need permission. There you are.
Here I am. Okay, I am, like I said earlier, I'm Jim. I work in Group 4. The opposite of Marilyn. I've been here for about, 2 months now? Retired from the public school system after 26 years of teaching in middle school, high school, and elementary. And I'm absolutely thrilled to be here because I get to benefit from the hard work of these ladies here and as my students come into my room. My big focus is kind of taking these ideas, multiplicative, proportional reasoning, the structure of the number system, and starting to expand those. So what happens when we have irrational numbers? What happens with our integers and our negative numbers? And how do those kind of fit those same rules and properties of arithmetic? And that sort of leads us into everybody's favorite course in middle school, algebra. So that's kind of where I'm going to go. I'm not a big, I'm going to talk at you person, so we're going to do some math. Right? We'll wrap it up with that. So a big thing that I really focus on is this idea of algebraic reasoning. And a lot of the algebra that we all experienced when we were all sitting in classrooms is not that different from what, this is probably an extreme example, but not much different than this. We were given problems where we were solving for these variables without really any understanding of what that variable is, the connections of why we were even doing it, what's the purpose of it, and a lot of it has to do with the idea of what algebraic modeling is all about, and that is a huge focus of mine. So let's get the definition out of the way. So when you're talking about algebraic modeling, it's this idea that I have a situation. You think about what people do in the real world. I have this scenario, this situation, and I need to figure it out. I need to quantify it. I need to decide what things are really important. What do I need to measure? What do I need to count? What are the variables that really impact my answer, that make it make sense? Then I take those and I start to decide, well, how can I track them? How can I start messing with them? How can I collect that data? Do I use a table, a graph? Is there an equation I can write? I take those numbers out I put them in my table. I start messing around with them. I start playing around with them, and I'm starting to look for those patterns that we talked about. Put them back into my situation. Does that make sense? And then I start to say, well, I'm going to check my conclusion. Did my model really work? Was there something in error I made? And then, if so, I fix the model. If not, I talk to my partners and I share that with them. So it's all these things that we've talked about up here. And now that we know that definition, I passed around a nice little, what could be a very intriguing problem. And I know because we're all driven math people, you've all solved it. But to avoid that, I put the answers there, so you didn't have to worry about that. But what I would like you to do is to think about those 6 steps that I just went through. I'll put them back up here in a minute. What do you see in this problem? Do you see all 6 steps? And which ones is the textbook doing for the learner, and which one is the learner actually being asked to do? And I'll take some volunteers.
They're wet. I didn't drool on them.
What is the learner doing versus what is the textbook doing?
Well, the textbook's providing them the model, right?
Textbook's giving them the model. So they got number 2.
Textbooks identifying variables.
Textbook's identifying the variable. What is the learner having to do?
Crunching the numbers.
Okay, so they're probably doing number 3, and if they label it, probably 4. So am I doing the chirps per minute? Am I doing the temperature? They going back in and checking their model?
No.
Okay, so 5 and 6 aren't even there, and they didn't come up with the model, so why would they even go back and check it? This is the algebra that we all experienced, and I find it interesting that at the top of this it says problem solving. Of course, the whole page above it that I didn't put on here is all problems just like it, all without the word. And then, of course, now you're going to apply it in the word problem. So you've already done a million just like it. So let's guess what we're going to do here. We're going to put the numbers in and figure it out. So let's talk about how we do modeling over in Group 4. So one of the big things I do is a very kind of scientific and mathematical way of getting kids to think. So we do what I call a notice and wonder. And I do this around really rich scenarios that get the kids to start conjecturing. I'm going to have you do one with me in it that we just did recently. And these scenarios that I find are, there's all kinds of things. There's stuff we create, there's stuff that comes out of my science lessons. Some of them are video-based context or story-based context. And just get the kids thinking about mathematics. And as Marilyn said earlier, I don't just pull them out of my hat. I have a purpose as a math teacher. So one of my goals with my 8th graders right now is investigating linear, quadratic, exponential functions. How do they relate? How do they act? And describing those. So I would like all of you to do a notice and wonder with the video I'm going to show you right now. And you're going to have to watch quickly as this hopefully it loads.
We're having a little bit of technical problems today.
So basically this guy's doing a world record pyramid of pennies. Or not.
I noticed. Whenever you want it there.
Just show us with interpretive dance, too.
Now you're outside of my wheelhouse. I like the thought though.
Let's get the good one. See, that's probably after we switched mine into yours. That's all my stuff. You can close that out. Yeah.
Is it in your downloads folder? It showed that it downloaded.
Let me try it one more time. See if this. Oh, so there we go.
Here it is.
Oh my God. Wow, it's beautiful.
It's all about how you bait the hook. That's what they did too. Oh my goodness.
Wow. He doesn't have a dog. Or a toddler.
All right, so let's just play along here with me. What would you notice? What would you wonder with that situation? What was going through?
Pennies.
How many pennies? What else?
How many at the base?
How long did it take? How many on the base?
How tall is it?
How tall is it?
What does it
How much did it weigh?
How much money is it?
How much money is it? And you know what? These are all the questions that the kid they all came up with it. So now my next question, we went with the how many is it first. So we sort of all made estimates. So we putting names up there on the board, and they're all making their guesses and thinking, oh yeah, there's.
It would be 20.
You know, we make, I think a lot of them were like around 20,000, 10,000, and so we make high limits and low limits. So it sort of sets up that idea of, and I used to get this all the time, the kids would do all this numerical work and they'd get the answer and you look at it and go, how in the world does that even make sense? Well, these guys are already setting the parameters for what makes sense. And so their answer's in the middle here and they have their highs and lows, and now they're going to work. So if I turn you loose to do this, this is the first act of the 3-act math. Now you're thinking, you're engaged, I baited the hook, you're fully ready to roll. Then I say, okay, well let's go ahead and figure it out. So what kind of information do you think you need to know to be able to figure out how many pennies are there?
Yeah.
Go ahead.
Yeah, how many, your base,
What's
your square?
Okay. Anything
The
else?
first one.
Yeah. How many rows?
And how many high?
Okay.
How many fewer is each level?
Okay, so what I would do with the students is I move into Act 2, which I don't give them this information until they've asked for it. So they'll start working and all of a sudden they'll go, hey wait, how many pennies are in each little stack? That's an important piece. What is the base? So I give them that. And then some of them will say, well, what are the dimensions of the penny? Well, that's something they got to go look up. We got to do a little bit of research here. So they look up the thickness of the pennies, the weight of the pennies, and all of a sudden they're going to work. And there's trajectories of learning going on all over the place. And as they're building they usually start off with a table on this problem and they're working through and they're going, hey Marilyn, my answer is not what yours is. And instead of just, well, let's go through it together and see where we made our mistakes. And coming out of the public school, that's when I faint and thank these ladies. So they get this kind of information and they continue on their merry way. Now, of course, they start, I'm going to take a look at some of the student work here.
They continue on through break and lunch.
Yeah, so,
Our kids will stop eating, Alessandra, to continue.
yeah, so that was the cool thing. Kate actually, she started coming in during her class just to see what we were doing, and the kids are walking into me at lunchtime. Jim, do you mind if we use a computer and sit in here at lunchtime? And, you know, of course, I'm like, no, you can't do any of that. So they're in there. This one-day activity became 2 nights of homework that I didn't assign. They were just trying to figure out their next answers, and they were all heading down different roads. So you can see here, this is a student. Here's his notice and wonder. How many pennies are there to make one column? How many pennies did he stack to make the full pyramid? A little a times, I think he was doing an area formula for the base. Where did they get all the pennies? That's a good question. So they ended up, you know, they're making their tables, they're all comparing their tables, and they're flying through, and, you know, they're realizing, like, hey, we're multiplying 40 by 40 times 13. We're multiplying 39 by 39 times 13. And so here's this pattern and regularity starting to come flying out. Here's a little side trip. We had one group decided, how long would it take? So they took out the pennies and they timed themselves. Of course, I just had this stuff laying around the room, so they're timing themselves. How many can we stack in a minute? How many can we stack in a minute? They didn't like the results. They did it 3 times and took the average. I mean, talk about a mathematical and scientific process just coming flying out there. They determined that it was 33.3 hours to build the pyramid. So at the end of this, of course, there's no answer in the textbook. That's the scary part for us teachers. But there's an article that talks about how the guy actually spent 200 hours. So they weren't worried about their answer being wrong. They sat there and reflected on their motto and said, wait, we were racing to get ours stacked. He probably didn't race. He probably took his time, and I bet you at some point, he didn't have a dog, but he did knock him over at one point with his knee. And so they started to think about what are the things that interfered, and so my model wasn't right, not my mathematics, which is a shift in thinking. And so this is actually the students that went ahead and did the hours. We also had students go ahead and do the weight, but where I wanted to go was while they're playing around, I'm over there starting to enter my information on a spreadsheet, and all of a sudden they're starting to go, you know, I'm just teasing, and all of a sudden they're going, hey, that's a lot easier, because I'm clicking and dragging, and they're like, wow. I don't know if you know, have seen your kids are probably like mine. My grandmother, when she got her cell phone, read the entire book before she would ever turn the thing on. The kids of today's generation, they turn it on and let's roll. So that's all I had to do. They're like, can we use the computers? I'm like, yeah. So next thing you know, they're entering formulas and figuring out, they're throwing the questions out. Well, where do you think you get that? They're going on to the help functions. They're figuring out how they're entering the formulas, and all of a sudden you're seeing, see if this will actually work. Since no. So they're actually entering in things like, well, here's this cell, and then this one's going to be the cell times itself. The next one's going to be the cell times that cell times 13. And then all of a sudden they're wondering, man, how in the world am I ever going to do all this adding up of all these columns? And all of a sudden here's this little opportunity for me to introduce that summation idea. And it actually makes it make sense to them. They're like, wow, that's really cool. But they did all the problem solving to figure out how do I actually do that before I click on the one button and they go, ah, should add a V8. And then they discovered, like, hey, I can do this graph. Well, now we're starting to bring out these quadratic functions, and so they've done all this conceptual work and realizing how all this stuff works, and then my job is to start tying it together at the end. And they've already entered the equations, they've made graphs, they've made their tables, and they're looking at how it grows. So, in this situation, did you see all 6? So the kids decided what the variables were. They created their models. They played with the mathematics. They made sure they made sense. Then they shared their models with each other. Then as an extension, we figured out how big a pyramid we could make with $1 million. And then we went out in the yard and you know, kind of laid it out. Wish we could build it, but we don't have that many pennies.
So Jim, you guys have them work in groups then?
We sort of go in between partner pairs, groups, and sometimes they'll break off into individuals. Because with this problem, my main goal, and it really didn't matter which avenue they took, they're all going to end up with that quadratic relationship in the table and that pattern. And then wherever they go from there is just kind of following the interest. And
Right.
so what happens when we multiply that with this or combine these? And so from one 5-minute video clip, and it wasn't even 5 minutes,
Right.
you know, we learned how a quadratic function grows. We explored how to use a spreadsheet, which now we did some exponential functions, and they didn't even mess around with the table. They went and got the spreadsheet right out and started just plugging. As soon as they figured out what the formula was, they started just plugging those in. We learned how to write formulas for quadratic functions and investigated the summation feature, all within 2 days, mostly driven by them, with me just finding a good thing to get them hooked. So that really represents kind of how I go about things. A big portion of, that's it. So a big portion of my curriculum outside of this, it's a lot of algebra focused, but we also do some things around geometry, statistics, but a lot of them are coming right out of this same idea, where the kids play around with something, and all of a sudden, you know, Nathaniel keeps telling me, I'm going to invent a hat with a light bulb on it. Because he'll go, "Ooh, and guess what I'm seeing?" And so we're using the little thing from the Minions light bulb. We all do it like Gru, and I have them write claims, which is taking the theories that all of us, like, here's one that everybody will remember. Remember the teacher writing on the board, the sum of the angles of a triangle equals 180 degrees? So we had the kids playing out with triangles, and they're ripping them off and folding them around, and pretty soon they're going, "Hey, this always makes a semicircle." So we start writing those as claims, and then we analyze each other's claims and work on modifying the language until we all come to an agreement, like, here's our theory. You know, and it's, you know, and then we'll come across, we'll do some investigation, like, "Hey, that guy found the same thing we did." So that's group 4 math. That's how we kind of roll in there, and so that's all I got.
So